Hey there, and welcome to another deep dive. We're going to be today exploring a special group of numbers. You use them every day, probably without even realizing it.
That's right. We're diving deep into rational number.
I like it, diving deep. So we've got some excerpts from a mathematics textbook, kind of help guide our exploration today. And trust me, we're about to uncover those aha moments that make these numbers really click,
Absolutely.
no matter your level with math.
And you might be surprised by how often rational numbers just kind of pop up in your everyday life.
Yeah, for sure. Okay, so before we get too far, let's start with the basics. What exactly are rational numbers?
So think of it this way. Have you ever tried to split a pizza equally or maybe measure out ingredients for a recipe?
Yeah.
You're using rational number.
So rational numbers are basically just fractions.
You got it. The textbook defines a rational number as any number that can be written in the form of PQ, where P and Q are integers.
Okay.
There's one important rule, though. Q, the denominator, it can't be 0.
Right, because you can't divide by 0, big no-no in math. But why are these rational numbers so important? It's not like we always need fractions to solve every problem, right?
Well, imagine trying to solve the equation 2x equals 3 using only whole numbers.
Okay.
You'd be stuck.
Yeah.
So rational numbers, they bridge that gap and give us those solutions where those whole numbers just aren't enough.
So they're like the missing puzzle pieces in our number system.
Exactly. They unlock a whole new level and allow us to tackle way more complex problems. It's like upgrading from a basic calculator to like a super scientific one.
Yeah. Now that's some upgrade I can get behind. But there's got to be more to rational numbers than just filling in gaps, right? Our source material mentions something called properties of rational numbers. What does that even mean? Do numbers have personalities now?
You could say that. These properties are like superpowers
Okay.
that make rational numbers so uniquely powerful and useful. Let's start with closure.
Closure. Sounds kind of exclusive.
It is, in a way. Closure basically means that when you add, subtract, or multiply any two rational numbers together, the result will always be another rational number. It's like they have this exclusive club.
Right.
And no matter how much they add, subtract, or multiply amongst themselves, it's always another member of the club.
They stick together. But the textbook mentioned there's a slight catch with division, right?
Yes. They love to add, subtract, multiply, but they can be a bit picky with division. Usually you'll get another rational number when you're dividing, which is great. But if you try and divide by 0, it's like you're breaking the club rules.
Oh, so close. What else can these rational numbers do?
Absolutely. Now let's talk about two very important numbers in the rational number world, 0 and 1.
Okay. Those seem pretty basic. What's so special about them?
They might seem simple, but they play super crucial roles. Let's start with 0. So in the rational number world, 0 is what's known as the additive identity.
Meaning?
Is if you add 0 to any rational number, you just get that same rational number back.
Okay.
It's like adding nothing at all.
0. Always keeping things simple. What about 1 then?
1 is the multiplicative identity, meaning any rational number multiplied by 1 is going to stay exactly the same.
Okay.
Yeah.
So 0 is the master of addition, and 1 rules the world of multiplication.
You got it. And those roles, they might seem kind of obvious, but they form the bedrock for a lot of more complex math concepts.
Wow, so even the simplest things can have huge implications. Our source material also dives into negatives and reciprocals. What are those all about?
Great question. So remember, every rational number can be represented as a fraction, right?
Right.
Well, each rational number also has what we call an additive inverse. It's basically its opposite.
So like a negative version of itself.
Exactly. For example, the additive inverse of 2/3 would be negative 2/3. And when you add a number and its additive inverse together, they cancel each other out, resulting in 0.
It's like a mathematical tug of war that always ends in a tie.
I like that. I like that.
What about reciprocals?
Reciprocals, or multiplicative inverses, are all about multiplication. Basically, it's the number that you multiply a rational number by to get 1.
Okay, so for 2/3, its reciprocal would be 3/2, because when you multiply those together, you get 1, right?
You're on a roll. You got it down perfectly.
Okay.
There's one exception, though. The number 0. 0 actually doesn't have a reciprocal.
Why not? Is it another one of those math rules that just doesn't make sense?
Not quite. It's just that there's no number that you can multiply by 0 to get 1 as a result.
Right.
It's like trying to fit, a square peg in a round hole. It just doesn't work.
Makes sense. So we've covered a lot of ground here. Closure, commutativity, associativity, 0, 1, negatives, and reciprocals. Anything else we need to know about how these properties work?
One more important property to cover, distributivity.
Okay, lay it on me. What's so special about this one?
So distributivity basically tells us how multiplication interacts with addition and subtraction when it comes to our rational numbers. It basically allows us to multiply a sum by multiplying each add-in separately and then adding the products.
Could you give me an example? Visuals always help my brain connect the dots.
Absolutely. The textbook uses a great example. Let's say we have -3/4 multiplied by, in parentheses, 2/3 minus 5/6. Distributivity says we can distribute that -3/4 to both the 2/3 and the -5/6 inside the parentheses.
So it becomes -3/4 times 2/3 plus -3/4 times -5/6.
That's exactly it. That's exactly it. Now, you might be thinking, why not just solve what's in the parentheses first? But when you're dealing with more complex equations, understanding this property can really simplify things significantly. It's all about working smarter, not harder, right?
Distributivity.
Yeah.
The ultimate math shortcut. So we've talked about these rational numbers in the abstract, but how do we actually picture them? Do they have a place on the number line?
That's a great question. And yes, rational numbers definitely have their own spot on the number line. Remember all those gaps between the whole numbers that we talked about earlier? Well, rational numbers fill in a lot of those gaps.
Okay.
Yeah.
Help me visualize this. How does it work?
Okay, so picture a number line.
Okay.
0 in the middle. Positive numbers to the right, negative numbers to the left.
Got it. Visualizing it.
Perfect. Now, to represent a rational number, let's say 3/4, we would divide the space between 0 and 1 into 4 equal parts because our denominator is 4. Then we count 3 of those parts starting from 0 because our numerator is 3. And that, my friend, is where 3/4 hangs out on our number line.
So for a rational number with the bigger denominator, we would just divide that space into more equal parts, right?
Exactly. And it works the same way for negative rational numbers, except we'd be on the left side of 0.
This makes these like abstract rational numbers feel much more real. It's like we've given them a physical address on the number line.
I love that analogy. And speaking of the number line, have you ever considered just how many rational numbers we can find between any two given rational numbers?
Never really thought about it. I guess there are only a few, depending on, how far apart the numbers are.
Get ready for a mind-blowing fact. There are actually infinitely many rational numbers between any two other rational numbers.
Wait, hold on. Infinitely many. You're telling me I could spend my entire life finding rational numbers between two others and still not find them all?
That's exactly right. It's a bit mind-boggling, but it's incredible and fascinating. Let's take 3/10 and 7/10 as an example. You might initially think of a few rational numbers between them, like 4/10, 5/10, 6/10. But here's the catch. You can always find more by just increasing the denominator.
You mean like writing 3/10 as 30/100ths and 7/10 as 70/100ths?
Precisely. Suddenly you've got a whole bunch more rational numbers to work with. 31 over 100, 32 over 100, and so on. And the best part is you can keep doing this, making the denominators larger and larger, and you'll never run out of rational numbers between 3/10 and 7/10.
Wow, that is mind-blowing. It's like the closer you zoom in on the number line, the more crowded it gets with these rational numbers.
You've got it. And this concept is actually known as density. Unlike whole numbers, which are more spread out, rational numbers are densely packed together with no space wasted.
So does that mean there are absolutely no gaps on the number line?
Now that is a fantastic question, and one we'll delve into right after a quick message.
We're back and ready to tackle that cliffhanger. If we can always squeeze in more rational numbers between any two others, does that mean there's no gaps on the number line at all? It really makes you think about the very nature of numbers, and infinity and all that.
Yeah, it's a question that's puzzled mathematicians for ages. It does seem kind of counterintuitive. I mean, we tend to think of numbers as individual points, stepping stones along a path,
Exactly. But this whole idea of rational numbers being so dense suggests the number line is Smiever, almost like a line, with no room for any holes.
It's a really powerful way to think about it. But here's the mind-blowing part. As plentiful as rational numbers are, there are still some special numbers hiding out there that we haven't accounted for.
Wait, there are even more numbers beyond rational numbers.
Yeah.
Okay, now you've got my attention.
Mm-hmm.
What are these mysterious numbers then?
These elusive numbers are called irrational numbers. And as their name might suggest, they can't be represented as those simple fractions that we've been talking about.
Irrational numbers. They sound like troublemakers.
They're actually quite fascinating and super essential for understanding the complete number line. But exploring all their wonders is a deep dive for another time.
I'm already adding it to my list. So to wrap things up, let's recap our rational number adventure today. We started by defining them as those those well-behaved numbers that can be expressed as fractions.
Yeah, and we discovered that these fractions, they hold incredible power, incredible flexibility, and we can thank those unique properties for that.
Right. We've got closure, which keeps those rational numbers in check, like in their little exclusive club. Then there's commutativity and associativity, giving them that flexibility with order and grouping for addition and multiplication.
And let's not forget about 0 and 1. Those might seem like simple numbers, but they play such crucial roles as those additive and multiplicative identities.
Oh, and who could forget about negatives and reciprocals? Always there to provide balance, bring it back to 0 or 1.
And finally, we have distributivity, the ultimate facilitator, making sure that multiplication plays nice with addition and subtraction.
It's honestly amazing how these properties take these simple fractions and turn them into, like, these mathematical superheroes. We then explored their spot on the number line and found that they fill in a lot of the gaps between those whole numbers.
Yeah, and that's where we had that mind-blowing encounter with the concept of density, where those rational numbers, they're so tightly packed together that there's infinitely many between any two that you choose.
Yeah, it's like trying to count the grains of sand on a beach. You know what I mean? It's awe-inspiring. But even with all this density, all these numbers, we learned that there are still some gaps out there, some mysteries yet to be uncovered.
Exactly. And those gaps are filled by those intriguing irrational numbers. Definitely a topic we'll have to explore more another time.
Absolutely. So until then, keep exploring, keep questioning. And remember, even in this world of numbers, there's always something new to discover. Thanks for joining us on this deep dive into the fascinating world of rational numbers.